And it's code in the D to give the keyboard a punch. Then cross, correlate, and a break for some lunch. Correlate, tabulate, process, and screen. Program, print out, regress to the mean. And it's, oh boys, can't you code it? And program it right. Nothing ever happens in this.
In Stata, there's a couple of things that aren't always intuitive. I call them gotchas. One of them has to do with precision of your data, and the other with missing values. This video is going to address the issue of how Stata deals and treats missing values. It's actually quite powerful, and there's a lot of good news here for us for managing our data. I've got Stata up and running, and unlike the other videos, I'm not going to use the general social survey. I'm going to make up a small data set to use for an example. If you look in the program editor window, you can see my program in lines 1 through line 16. I'm going to clear out any Stata data set that might exist. I'm going to use the input statement to create a data set that's going to have 3 variables. 2 of the variables are numeric. X and Y are both numeric, and they'll be stored as bytes. Z is a string variable, and it'll be 8 characters wide, up to 8 characters wide. Lines 3 through 17 provide all the data. So the first data record has the values of 1, 2, and cat for X, Y, and Z. The second data record has the values of 3, 4, and dog. The next data record is 5, 6, and blank. And I mention that blank because a string variable that's left blank is treated as missing. And then we have 7, 8, and unicorn, and then period, 9, and snake. For numeric values, period means missing. It's the most typical missing value in Stata. They call it sysmiss, and it's the default missing value. It turns out that in Stata there's 27 different missing values you can assign to numeric data. And the way Stata works is it looks at how your data are stored. There are different storage types. It takes or reserves the top 27 values of that storage type for missing values. Missing values are very large positive numbers, and there's a hierarchy or precedence to them. So the smallest missing value is a period, and then you have period A, which is 1 unit larger, period B, which is 1 unit larger than period A, and so forth. So we have 27 missing values. Why do we want 27 missing values? Sometimes it's important to track why your data are missing. On a survey, for example, you might have a skip pattern where asking certain kinds of questions are inappropriate because the question was skipped. And so you might assign the value of period A to that missing value. On the other hand, you might have somebody who refuses to answer, and you might list that as period B. And finally, you could have somebody who doesn't know how to respond, doesn't have an answer, and you might distinguish them by using a period C. So we have all the letters of the alphabet, period A through period Z, as missing values, and then just the plain old period. I want to give you one other suggestion here about missing values. If you look down at line 13 of my program editor, you'll see that my X, Y, and Z values are 15, 16, and then I'm using double quotes around 2 blank spaces. It turns out then the value of Z is not missing for this case. It's in all the other cases where there's no animal listed, it's null and therefore missing, but in this case there's 2 spaces, and that's considered to be a non-missing value. Let's go ahead and highlight this block of code. You'll notice at the bottom I'm going to use the list command I'll read in the data set, and I'll use the list command to list everything out. So let's see if we can make some sense of this. If we look at the X variable, we see that in cases 1 through 4 I have valid values, 1, 3, 5, and 7. Case 5, I have a missing value or a period. That's my sysmiss, and that's a large number. It's the largest number that can be. It's actually the largest number that can be stored as a byte minus 27. Case 6 has a value of 10. Case 7 is missing. Let's go down to case 10. You can see I have a period B there. That will be treated as a missing value by Stata as well, and it's actually a different number or a different missing value than case 7. The variable Y, we can look through there and we see we have missing values for cases 6, 7, and 9, and 12. Moving over to the string variable, the z variable, it appears that we have true data for cases 1 and 2, cat and dog, cases 4 and 5, unicorn and snake, case 6 for rabbit, and case 12 for squirrel, and that all the others are non-missing. But I mentioned that when we look at record 11, what appears to be a missing value there is actually a true value. It's 2 blank spaces. And you'll see what that looks like in just a minute. We're going to use some Stata commands here to look at all these different values. So going back to my program, if we look at lines 20 through 21, I'm going to list the values of x under 3 different conditions. The first condition is that if x is less than period, or less than the missing value. Again, missing values are large positive numbers. Then I'm going to list all the values of x if x is greater than or equal to missing. And then finally, I'm going to list x if x is greater than the missing value. Let's see what we get here. When we list x if x is less than missing, we get all the valid values of x. Anything that's missing on x is not here. So you can see that record number 5 is missing, record number 7 is missing, and so forth. And that's pretty much what we would expect to find. On the other hand, if I list x, the values of x, if x is greater than or equal to missing, it lists out record 5, record 7, and record 10, which are coded as period, period, and period B. Finally, if I list out all the values of x if x is greater than period, greater than missing, I get only the period B. And I'm showing you this to reinforce the notion that the missing values are in a hierarchy, and it goes period, period A, period B, and so forth through period Z, and that underlying these labels are actual numbers. Let's go back to our program, and let's do the same thing for the y variables. I'm first going to list all the data out. Then I'll list all the values of y when y is less than missing, when y is greater than equal to missing, and when y is greater than missing. We'll go ahead and look at all the data here. We can see in that y column that we have good values for cases 1 through 5 and 8 through 11. So when we list all the valid values, list y, the values of y if y less than or equal to period, I'm showing them all there on the side. List values of y if y greater than or equal to missing, I should get my period A, and through period Z if they exist, and I do. And then finally, if I look at all the values of y that are greater than missing, it only includes that one single missing value, that's period A. Back in the program, we're now going to look at the string variable. And string variables are a little bit different. A string variable is considered missing if it's null, if it has no spaces and no character values. So again, to do this, I'm going to list out all the values so we can look at them again. I'm going to list values if z is not equal to missing, not equal to null, and list out all the values of z if z is equal to missing. Now in my code in lines 30 and 31, I'm using the not equal convention in Stata, which is an exclamation mark equals or a tilde equals. I prefer the exclamation mark. And then I have double quotes with no space. That's a null value. In line 31, I'm going to list the values of z if z is, and I'm using 2 equal signs here to indicate an equality, if z is equal to a null. So the first one should list out values of z that are not missing, second one if they are missing. Now I'm showing you all the data again because it appears if we just look at the values of z that we're missing on case 3 and case 7, 8, 9, 10, and 11. But the truth is, if we list all the non-missing cases, which I've done here, you can see that case 11 shows up as non-missing. And again, we know that because when we input the data, we have 2 spaces here, not null. And then finally, I'm listing all the records that have missing values, and that's 3, 7, 8, 9, and 10. So that's pretty much how missing values work, and there's always some good news and bad news here. I'm going to give you the good news first. Let's go ahead and calculate a new variable that's called x plus y, and it'll be the sum of x and y. And I'll list that out and show you what that looks like. And then let's summarize all of our data. We'll summarize x and y and x plus y. So here I am. I'm going to use the generate statement to create my addition variable. I'm going to list the cases out and then issue a summarize command. So you can see that when I generate this new variable x plus y, I get a notice from Stata, a message from Stata that there were 6 missing values generated. And look at the listing. You can see why there's missing values. Stata can easily add 1 plus 2 and 3 plus 4 and so forth, but down there on record number 5, what does it do with period and 9? Stata knows that the period, even though it's technically a number, means it's missing, and says if I'm trying to add 2 numbers and I only have 1 number, I don't know what to do with this, so I will assign a missing value to it. And that's good news because that's the appropriate thing. That's what we'd like any statistical application to do. It can't make up numbers for us. It surely shouldn't put 9 in there because 9 plus missing is not 9, it's missing. Stata does this with almost all calculation and generation of variables. It excludes the missing values. Let's go ahead and look at our summarize command. You can see if you look at the number of observations that we have 9 observations for x, 8 observations for y, no observations for z, and 6 observations for x plus y. And that's kind of an interesting outcome. It's clear why z is missing on all the cases because summarize is a statistical function and you can't calculate statistics on character variables. It tells me that x is missing, so we have 12 cases. The x variable has 9 valid cases. The y variable has 8 valid cases. But x and y together have a total of 6 valid cases. And if you look at the listing above, you can see that it's record number 1, record 2, 3, 4, 8, and 11. Those are my valid cases, and therefore Stata can only calculate for those particular cases. Now, that's the good news. There's also some bad news. The bad news is that if we're not careful when we create new variables, we can make a mistake. So here's what I'm going to do. I'm going to create a new variable called xInd1. I'm going to use the x variable, create an indicator variable, and since I'm going to make 2 of them, I'll label this 1. The first thing I do is use a generate statement to create the new variable equal to missing. I have 12 cases in my data set. This is going to put 12 missing values in records 1 through 12. Then I'm going to selectively change those missing values to either 0 or 1 depending upon the value of x. So I'm going to make an indicator or dummy variable out of this particular measurement. My first replace command says replace this new variable xInd1 with 0 if x is less than or equal to 10. That is, I'm going to make a variable where every case less than 10 is coded 0 and every case less than or equal to 10 and every case greater than 10 is equal to 1. My second replace says replace xInd1 equals 1 if x is greater than 10. And then I'm going to list these values out. So let's go ahead and highlight this block of code and run it and see what we get. So I want you to look closely at record number 5 and record number 7 and 10 and so forth. Sure enough, every value that's greater than 10 is coded as a 1. But the missing values are actually greater than 10 because remember they're large positive numbers. So I've taken data that are missing and now coded them as if they are not missing. And it's probably not the outcome I wanted. So if you'll go back to the program file now, I'm going to create a new variable xInd2 in exactly the same way. But in line 47, I'm changing my if statement a little bit. I'm going to replace this variable xInd2 equals 1 wherever x is greater than 10 and x is less than missing. Let's go ahead and see how that works out. This is the outcome I wanted. And this is the gotcha in Stata. If you're not careful and you just say replace some value with something else when it's greater than some value, it will also include the missing values. But here you can see that record 5, 7, and 10 are missing on xInd2, which is really what should have happened. The last thing we can do with our variables, with our missing values, is we can define labels for them. Now that's not exactly correct. You can't change the label for the sys-miss or for the period, but for any of the others you can. So I'm going to use a label define statement. I'm going to call it miss, and I'm going to have all the point A missing values, period A missing values labeled as NA for not applicable. I'm going to take all the point B or decimal B missing values and have them labeled as IAP for inappropriate. And I'm going to assign those labels to my X and Y variables, and we'll list them all out. And there you go. You can see them in line 10 and record 9 and record 10. So again, if you're keeping track of why your data are missing, having this label function is a really nice feature in Stata. Well, there you go. That's how Stata deals with missing values. I hope you found this useful. And as usual, if you have any questions, please contact me and I'll do my best to answer them.
And it's code in the data, give the keyboard a punch, then cross, correlate, and a break for some lunch. Correlate, tabulate, process, and screen. Program, print out, regress to the mean. And it's, oh boys, can't you code it? Program it right. Nothing ever happens.